long pass measurement, I take fiber to the external mirror and send across the room to the window where is another mirror and back to the photodiode. Signal is quite fluctuating, but the average signal is good, but the fitting is not good. It gives fringes, and in residue we see that scan is in steps. Calibration can be done with a syringe filled with methane in front of photodetector. Calibration line, how it looks. Methane cell from an old laser. Back reflection into laser, which made everything unstable. Now I move detector sideways. Fringe is changed. They are not jumping up and down very much. If I move fiber end close to the lens, then we get these fringes. Another collimator. This is how residual looks with methane line. Conditions without methane line. There is a bump. Reflecting back from mirror, bump is more severe. Laser beam across the hallway. We direct the beam back. The light which comes back has nice diffraction stripes. Amazing, it works fine over this long distance. Unfortunately, in first I see nothing. But actually it looks different. There is some bump here now. Now I just leak methane. I put syringe under the beam and it is leaking through the hole. With closed windows, the curve is accelerating faster downwards. Photodiode is on largest gain and there is no lens. Oscilloscope triggers faster. It could be that another absorption line is starting here. Kind of something, for example water, CO2. Now window has been closed for some time and the drift is slower here. The shape resembles interference fringe. After opening the window broadly, widely, the slope starts to go. Change little bit beam direction with mirror mount and shape changed completely. Made the calibration cell from vodka flask and filled a little bit in methane. And this is how it looks when there is significant amount of methane. Also in absorption signal we see nice dips. The glass bottle gives substantial signal. For the length of the bottle, get deeper dip. Bottle short and bottle wide. Inside this bioreactor is not enough methane produced yet. This can be checked by putting in the beam. Trying with lens anti-reflection coated 1.5 microns. So in front is a lens 5 cm focal distance anti-reflection coated and the trace looks quite smooth. Sometimes fringes are smaller in amplitude at higher current. Here we have 2 milliseconds and in 1 millisecond there are 4 steps. There are 64 intensity steps. The path is out of the lab through the building and back. We have modified the fitting to remove a parabola from this curve. And then we have a flat curve and these are the steps. And this is then residual when methane line is subtracted. Produce some methane in the path. Put glass bottle with methane in the path and we have a methane dip. Actually there is methane dip across the building. And on the screen also we have nice methane dip. So this idea to subtract polynomial from everything first and then to know where is methane line and fit their amplitude, it helped. First time we have a stable signal. Lenses are anti-reflection coated, that helped a lot. When on oscilloscope one can see that there is a dip little bit. Can compare dip to the step size, this micro steps, 60 micro steps, 64 micro steps. Big step 35% minus small step 14% is 20%, and these are 64 micro steps, so one step is 0.3%. So this is 0.3% of absorption. Transparent calibration cell from cooking bag. are called baking sleeve, have good gas retention, and we see that step size is different. Here it's small and here it's large. Here is small, here is the smallest, and here is the largest. So step size is not exactly measure of very good precision. The fit is not correct. Fit shows less values than actually. So if we assume that one step point free, so it is 1%, 2%, 3%, for about 5% absorption. And this looks consistent. If this to this is 20 and this is 5. Absorption in 100 meters, it is more than 0.3%. Because my fit is not correct, it is using too long data piece where it is flat. Should limit the fitting region to this. Like with open window, methane concentration slightly decreases in the building. The building with closed windows, the amplitude stabilized. Retroreflector array, 3D printed. Half cube retroreflectors impossible to work. Fringes not coated.